Chapter 7 is on powers, roots, and radicals. We're going to look at a few examples from each section in Chapter 7. We're going to deal with powers, roots, and radicals in a couple different forms. The first set of examples we're going to look at will be express in simplest radical form. So we're going to express the rational exponent in simplest radical form. So example 1, I'm going to have 125 to the negative 1/3 power. When I'm working with these problems, I'm going to look. I have a degree over an index, so base to the degree over the index. I'm going to look at the index. If 125 is a perfect cube, I'm going to take the index first. So the cubed root of 125 to the negative first power. Well, I know the cubed root of 125 is 5, so I'm going to have 5 to the negative first power. Now, 5 to the negative first power is not a negative number. It's just 1 over 5 to the first, which is the same as 1/5. Example number 2, again, we're expressing in simplest radical form. Example number 2, I have 25 to the 3/2 power. I'm going to look at 25, my base, to the degree over index. If 25 is a perfect square, because I have an index of 2, I'm going to take my index first. So my index first, I'm going to have the square root of 25, all to the 3rd power. Now, the square root of 25 is 5, so I'm going to have 5 to the 3rd power. I know 5 to the 3rd power is the same thing as 125. Let's practice one more of those. Last example of these, I'm going to have a negative 27 to the 1/3 power. Again, I'm going to look at degree over index. Is 27 a perfect cube? Negative 27 is a perfect cube, so I'm going to take that first. The cubed root of 27, all to the 1st power. Well, I know the cubed root of a negative 27 is a negative 3, so I'll have a negative 3 to the 1st power, or my answer will be negative 3. So, I've just expressed all 3 examples in simplest radical form. I'm going to move on. The next thing I'm going to look at, the next set of directions I'm going to look at, are going to say just simply simplify. Alright, so we're going to simplify a couple different things. First, I'm going to start out with a problem like this. We have x to the 5th y, the cubed root of x to the 5th y, over the cubed root of xy squared. Now, in order to be in simplest radical form, I must not have a radical in the denominator. We cannot have a radical in the denominator, so I have to take care of that. So I'm going to ask myself, how many more x's do I need to take an x out of the cubed root? Well, I need 2 more x's to be able to take an x out. How many more y's do I need under the radical to be able to take 1 out? I need 1 more y. Whatever I do to the denominator, I have to do the same to the numerator, so I'm going to multiply the numerator also by x squared y. Now, I'm going to go ahead and take care of this denominator first, because really, I've got 1x, 2, 3, group of 3, I'm going to bring 1 out. Y's, I have y squared, and y, I have y to the 3rd, cubed root of y to the 3rd, it's just y, so I did my job in the denominator. In the numerator, I'm going to go ahead and start out by multiplying straight across and keep them inside the index, because each has the same index, so I can multiply inside. X to the 5th times x squared is x to the 7th. Y times y is y squared. And now I'm going to simplify if I can. In the numerator, I have some x's that I can bring outside of the radical. How many groups of 3 do I have? I have 2 groups of 3, or x squared, and I'm left with 1x. I'm left with 2 y's all over xy. In simplest radical form, well, I have an x squared and an x outside of the radical, so I can go ahead and divide that. X squared divided by x is x to the 1st, so I'm left with x, the cubed root of xy squared, all over y. And that's my final answer. Next one we're going to look at, again, my directions are going to be simplify. So we're going to simplify And I'm going to go ahead and simplify 3 over 5 minus radical 2. Again, I'm not in simplest form until all my radicals are out of the denominator. But in order to get this radical out of the denominator, I cannot just multiply by the square root of 2. I have to multiply by the conjugate. Well, the conjugate of 5 minus radical 2 will be 5 plus radical 2. And whatever I do to one half of the equation or one half of the problem, I have to do to the other. Now I'm going to go ahead and FOIL. FOIL. In the numerator, well, I just really have to distribute that 3. So distribute the 3 to the 5 and I'll have 15 plus 3 to the radical 2 will be 3 radical 2. Now in the denominator, I'm going to finish by FOILing. 5 times 5 is 25. 5 times radical 2 is 5 radical 2. Negative radical 2 times 5 is negative 5 radical 2. Negative radical 2 times radical 2 is 2. In the denominator, my radical signs cancel out, which is exactly what I want. And I'm left with 15 plus 3 radical 2 all over 25 minus 2. So that's going to give me 15 plus 3 radical 2 all over 23, and that is my final answer. All right, last problem I'm going to go ahead and look at. Our directions are going to read, solve for x. Solve for x, I'm going to add one thing. Find all solutions. So my problem here, x to the 8th minus 25, x to the 4th plus 144. I need to find all solutions. How many solutions do I have? Well, in this problem, I have 8 solutions. That's my highest degree. Anything above 2 degree is going to be factored. So we're going to factor this equation. Now, I noticed right away that I have what looks like a perfect square trinomial. The square root of the first, square root of x to the 8th is x to the 4th. The signs are the same. They're positive. They multiply together to be positive, add up to be negative, so they're both negative. However, the square root of 144, 12 and 12 does not add up to 25. 12 and 12 is 24. I need 25. Therefore, we're going to use 9 and 16. There's one factor. We can continue to factor each of these problems. We have 2 difference of squares. So in the first problem, x to the 4th minus 9, I have a difference of squares, so I know I have 2 different signs. The square root of x to the 4th is x squared, and the square root of 9, 3 and 3. Second problem, I have a difference of squares. The square root of x to the 4th is x squared and x squared. The square root of 16, 4 and 4. I cannot factor, so I'm going to have to set these equal to 0 and solve each for x. So I'm going to move the 3 over and have x squared equals negative 3. I'm going to take the square root of both sides, and x is going to equal plus or minus I radical 3. On this one, x squared is going to equal 3. I'm going to take the square root of both sides, and x is going to equal plus or minus radical 3. X squared equals, move the 4 over, a negative 4. I'm going to take the square root of both sides, and x is going to equal plus or minus I. Well, the square root of 4 is 2, so I'm going to change that around to be plus or minus 2i. These are solutions, these are solutions, these are solutions. The last one, I can still factor this last one, so I'm going to make 2 smaller factors. Difference of squares, I have x and x. The square root of x squared is x and x. Square root of 4, 2 and 2. So x is going to equal a negative 2, and x is going to equal a positive 2. So now my final answer, x equals, I have 1, 2, 3, 4, 5, 6, 7, 8 solutions. Plus or minus I radical 3, plus or minus radical 3, plus or minus 2i, negative 2, and a positive 2. And those are all solutions for x. Chapter 7 covered a wide range of topics, a lot of manipulations with radicals, a lot of simplifying. I hope each one of these examples helps with your preparation for the test.